Good morning. Today I'm going to talk about our recent work on the open source approaches for location cover models. This project has been done in collaboration with Professor Alan Murray from University California of Santa Barbara. I'm Huanfa Chen, and I'm a lecturer in Center for Advanced Spatial Analysis at UCL. So my talk will be broken into 6 parts. First, I'll talk about location cover models. These models have been used for the selection of facility sites, and it is a type of spatial optimization models aiming to locate facilities and to provide optimal coverage for demands. There are many models in this family, and 2 representatives are the MCLP and LSCP. So MCLP is a short name for maximum cover location problems. The objective is to maximize the coverage of the customers or the demands with the constraint that the number of facilities is fixed. However, in this problem, not all demands should be covered. And on the other hand, the LSCP, which full name is location set covering problems, it aims to minimize the number of facilities needed to cover all the demands. So in this problem, all the customers must be covered. In this project, I will focus on these 2 problems. So where can we find the implementations of these models? There are 3 main sources for these models. The most common one is the commercial GIS software represented by the location allocation analysis in ArcGIS. However, this package is limited in several aspects. Firstly, it uses the heuristics to solve these problems, meaning that there's no guarantee that the optimal solutions will be obtained. Secondly, it requires a spatial network before we use the models, so it is not suitable for Euclidean distance metrics. Thirdly, as ArcGIS is a black box, the users cannot look into the details of the algorithms, so the reproducibility is unknown. The second source for these models is the custom software, which is quite popular in papers and academia. And these codes are developed by the researchers, and they use the codes for their publications. However, they rarely release the code to make them publicly available. So there is a similar issue with the ArcGIS, that the reproducibility is also unknown. And it's also very difficult to validate and reproduce. And as you may know, it is very challenging for some junior researchers to implement the models by themselves. The third source for these models is the open source. So far, open source is not popular for location cover models, but it is promising because it guarantees the reproducibility. Talking about open source and reproducible GIS, there are 3 main components that makes a study reproducible. The first is that the data should be available, and the second component is that the code used and the documentation should be available. This highlights the importance of open source software. And the third component is that a correct analysis should be performed. But what are the specific benefits of using open source for GIS and spatial analysis? There are 5 main benefits here. The first one is that the transparency and the reproducibility of a study can be guaranteed. The second is the wide access to and full control of the source code. And the third is that it allows for easy extension of the software. And the fourth point is that although open source doesn't mean free of charge, most of them can be used at no or very cheap cost, especially when we compare the cost to the license fee of the ArcGIS. And finally, using open source, you can attract more attention to your research. So in this project, our focus is a review of the open source location cover models, highlighting 2 important aspects of the workflow of solving a location cover problem. These 2 points are the nature of the service cover and the solution approach. And after intensive search, we identify 3 important and useful open source packages for location cover models. They are PySpatialOpt, MaxCoverR, and FLP Solver. And the first one is PySpatialOpt, which is based on Python. This package is recommended because there's no limitation in the space and the distance metric in this package. You can use it for network distance analysis or for Euclidean distance. And it uses an exact solution approach to solve these problems, meaning that the solutions from this package are guaranteed to be optimal. The second package is MaxCoverR, which is based on the R language. Similar to PySpatialOpt, there's no space in the space or the distance metric, and it also uses the exact solution approach to solve the problems. The third one is the FLP Solver. This package is based on Excel and Visual Basic. There's no limitation or restriction in the space and distance metric, but it uses a heuristic of simulated healing to solve these problems. So although you can solve the problems very quickly, there's no guarantee that the solutions will be optimal. And for comparison purposes, we compare these 3 packages against ArcGIS. As we discussed just now, there are several limitations in ArcGIS, like it uses the low network distance, and it uses a heuristic to solve these problems. So the links for these softwares are presented below.
Got 3 minutes left.
Thank you. For detailed comparison, we conducted 2 case studies. The first one is a study of a small size. We try to locate stores in San Francisco to cover 205 census tracts with 16 potential sites. This is the map of the demands and the potential facility sites. To solve the LSCP, we find out that all of these 4 packages obtain the optimal solution, which is 8 stores, and the computing time of the PySpatialOpt and MaxCoverR are the shortest. We also formulated 12 MCLPs, and all of these packages obtain optimal solutions, and the shortest computing time is obtained by PySpatialOpt and MaxCoverR. The second case study is to locate the police surveillance tower in a sub-area in the York of UK. We try to locate a number of sites to cover 591 crime incidents. As a result, in the LSCP, we can see that the optimal solutions is obtained by PySpatialOpt and MaxCoverR, but not from ArcGIS. And FLP Solver is not suitable in this case because it exceeds the limit of the Excel rules. And for the MCLP, the PySpatialOpt and MaxCoverR obtained optimal solutions for all of them, but ArcGIS only obtained 8 out of 12 problems. So what makes good software for location cover models? These 4 points are very important. Because of the time limitation, I'm not going into details of these 4 points. So as a short summary of this talk, we argue that open source software facilitates the reproducible GIS and location cover models. Although it is not very popular so far, it is developing very fast, and 2 representatives are PySpatialOpt and MaxCoverR. And in these 2 case studies, these 2 packages obtain optimal solutions for all of the problems in a short time, which significantly outperforms ArcGIS. So there are 2 important future directions for the open source location cover models. First one is to integrate with the open source GIS framework, such as spatial. And the second one is to develop a user-friendly graph user interface. This is very important for the application of the location cover models. And this project is going on, which is an attempt to integrate the open source location cover models with spatial. And all of the codes for this project can be obtained on GitHub. This is the link to the GitHub repo. And these are several key references for this talk. So this project has been published in a book chapter and also in a recent paper on Journal of Geographical Systems. It will be online question. So thank you very much.
I was just wondering, you mentioned the limitations of ArcGIS, but what do you think the main limitations of PySpatial Opt and Max Cover are compared to it, if there are any?
A good question. So in the process of this project, we are identifying several important limitations of these two packages. The first one is about the documentation. Because they are initial projects, the documentation is not perfect. Mm-hmm. And the second one is the integration with other GIS software. So far, they are standalone software, and to use them, we need to prepare for the input in a spatial format, which is quite difficult for some users.
We've got another question here from Nick. Thanks for the talk. You mentioned that location cover models hasn't had much open source development recently. Do you have any thoughts as to why this is?
Yes, I think there are two potential reasons. The first one is that most users and researchers are used to ArcGIS. When they want to use location cover models, their first response would be, is there any function in ArcGIS? Okay, there is one, so we use ArcGIS without thinking about the limitations of the function in ArcGIS. And the second reason is that most researchers in this field, they're used to use custom software and they don't release their code on GitHub. So there's a long story of why GIS researchers don't publish their code. And so I think these are two reasons why open source is not yet popular in this field.